Okay, so first off, warm-up-wise, I want to do one similar to one of the homework problems that some people struggled with. So if you have a radical, rewrite it as an exponent, like your square root of 2, turn that into 2 to the 1/2, and then make your base on your 16 2 by using 2 to the 4th. Then you rewrite your expression with your exponents set equal to each other. So if you struggled with the last one, number 75, I think it was, on the 4.2 homework, that is kind of how it should have gone. Today we're going to discuss some more logarithms. We're going to graph them first. So when you graph a logarithm, I would use your equivalent exponential function, get its points, and then since they're inverses, you can just swap your x and y coordinates, and those will be the points on the graph of your logarithm. So I'm going to do 2 to the x power with the x values of -1, 0, and 1, which gives me those points. Those aren't the ones on my logarithm, but like I said, those are inverse functions, so you can swap your x and y coordinates, and those will be 3 points that are on the graph of the logarithm that you actually want to have when you're all said and done. Be a little careful when you actually plot them, because I know some of the x coordinates aren't whole numbers. Those 3 points right there. Your asymptote was horizontal when you had an exponential. We're swapping it to the y-axis because this is our inverse function, so your graph should look something like that. Domain and range-wise, now your domain is restricted. It is only x values greater than 0, but your range, your y values, go up and down forever and ever. Let's do one that has some translations on it, because the order that you do these in is kind of important. So it's log base 2/3, which means I'm going to do 2/3 to the x power for my exponential function to get some initial points. Don't do any translations on the exponential points. Do your translations after you swapped it back to logarithmic form. So these would give me 3 points on my 2/3 to the x power. Swap those x and y values so that you have points on the logarithmic function. Excuse me. And then you're translating your logarithmic function, which is the points you have now, moving them right to and up 4. So the very final thing you do is your translation on those points to get your final points. So add 2 to your x values and add 4 to your y values. Then you'll have the points on the function that you really, really want. Let's see. Doing some mental math here. Okay, plot them. These are gonna be kind of ugly to plot. It's okay. And when you translated it right to, that also means that your asymptote that was along the y-axis is now translated right to as well, to the line x equals 2. And then draw your line in. Oh, that's not a very great end to that line, but domain is now from 2 to infinity because it's translated right, and your range is still -infinity to infinity. We're going to talk properties of logarithms, which is review from Algebra 2, but first property is if you have logarithm of 2 values that are being multiplied, you can expand that out into 2 separate logarithms with the 2 values being added together. So log base 7 of 8 plus log base 7 of 9. If you're dividing, you can expand it out into 2 logarithms being subtracted, numerator in the first one and denominator in the second one. If you have a radical, I would switch it to exponents because our last property is properties of exponents inside logarithms. You can rewrite that as bringing the exponent out in front and multiplying 2/3 times 2/7, times log base 2 of x. So those are all equivalent expressions. This one gets messy-ish. There's a couple ways you can do it, which I'll show you. I would switch it to exponent form first. So it's inside a cube root. I'm going to make that whole thing to the 1/3 power. Now your options are you can go ahead and bring that 1/3 out in front, or there's a second option that I'll show you later. So I'm going to bring that 1/3 out in front. and then have x over 4y squared inside. I'm going to expand that log of x over 4y squared a lot more. So that's going to turn into, make sure you put it in parentheses, it's going to turn into this whole new expression when I expand it. Since I'm dividing x by 4y squared, I'm going to do subtraction in between two logarithms here. And then I'm not done expanding yet until I have a single value with no exponents inside. You got to keep going. So that log of 4y squared is going to get expanded out again into a new expression in its own set of parentheses. You can do log of 4 and then log of y squared, which I'll go ahead and put the 2 out in front, being added together. I might distribute my negative at least. You could multiply the 1/3 in, but I'm going to at least distribute my negative and turn it into that expression. Second option, from where I was at the beginning, instead of bringing that 1/3 out in front and multiplying by it, I could take and multiply the exponents of everything that's on the inside and then do them individually. So I could turn it into that, and then log base a of x, I lost my a's on all these, realizing that now, but sorry, you could expand that out into those individual 3 logs right there. I should have a's on all those. Pretend they're there. Last thing, we are going to go the other way around and condense some logarithms back. So if you have 2 logarithms that are being added, let's rewrite it as a single logarithm with the terms inside being multiplied. That subtraction is going to put the 5 in the denominator if I condense those 2 things back together. So I'm going to have log base 2 of x times x plus 5 divided by 5. I might just multiply that x in there so that it gives you log base 2 of x squared plus 5x all over 5. If you have some coefficients out in front of your logarithms, those can be brought back inside as exponents, so I would start there. This would be log base a of m to the 3rd minus log base a of n to the 6th. Since they're being subtracted, you would want to condense that back into log base a of m to the 3rd divided by n to the 6th. Note, important notes, if you have division inside of a single logarithm, that is not the same thing as 2 separate logarithms being divided. What I have written and underlined in pink is what it should look like. It should not be 2 separate logarithms being divided. That's not how these work. This was a little bit of a complicated one, so let's see how it should go. I'd bring your exponents back inside. On this second expression, make sure the 2 and the n both get raised to the 5th power. Then if you start condensing, you have the first 2 logarithms being added, so I'm going to turn that into multiplication inside this one. I'm just going to leave it quantity 2n to the 5th for now. And then my last one, subtraction, so divide by your m to the 3rd. Simplifying a little bit, let's make it into 32n to the 5th by raising that to the 5th power. And then it's all over m cubed. You have m's in the numerator and denominator, so you can subtract your exponents and end up with 1.5 for your power of m in the denominator. And then you are finally all said and done.